angle of elevation of the top of an unfinished tower at a point 120 meter from its base is 45 meters. How much higher must the tower be raised so that its angle of elevation at the same point is 60 degrees? The angle of elevation of the top of an unfinished tower. Let's say this is the ground level, let's say, and you have an unfinished tower. So this is your unfinished tower. Okay. This is your unfinished tower, and the angle of elevation of the top of the tower. So let's say this is the top of the tower A. This is B, and this tower is unfinished in the sense that it will be constructed higher. Okay, a tower will be raised further to a greater height. So the construction is in progress, but for the time being, A is the top of the tower. It is given that the angle of elevation of the top of an unfinished tower. Top of an unfinished tower means the angle of elevation is given. That means the observer is at the ground. Let's call this point C. Here is the observer, and he is observing the top of this tower with an angle of elevation. This is the line. AC is the line of sight, and the angle of elevation here is given to be 45 degrees. Okay. So the angle of elevation of the top of an unfinished tower at a point distant 120 meter from its base. So what is the distance of this base of the tower from this point? 120 meters. How much higher must the tower be raised so that its angle of elevation at the same point, that means this point, same point, is 60 degrees. So let's say the tower is being raised here to a further height. Let's say this height. From A to, let's say, it is raised to a point A dash. This is the height by which the tower has been raised. Okay. Now, how much higher must the tower be raised so that the angle of elevation changes to 60 degrees? So now the observer, when he's observing the next, the higher point, his angle of elevation should be 60 degrees. So how much higher should it be raised? Okay, so this is your question. So if I start by saying, let the tower be raised by a height of X meters. Let the tower be raised by a height of X meters so that the angle of elevation changes from 45 degrees to 60 degrees. Okay. And let's say that the initial height of the building is, of the tower is H, where the initial height of the tower was H. Okay, so therefore AB is equal to H, and you have what? AA dash is equal to H. Okay, so here you have tan 45 degree in triangle ABC. In triangle ABC, tan 45 degree is equal to AB by BC. Tan 45 is 1, AB is H, and BC is 120. So you get H is equal to 120 meters. So we have got this height as 120 meters. Okay. Now we'll use the other triangle, which is triangle A dash BC. And what is the angle of elevation here? 60 degree. In triangle A dash BC, angle is tan 60 is equal to perpendicular here is A dash T divided by base here is the same BC. So tan 60 is um, root 3. A dash B divided by BC is 120. That means A dash B is 20 root 3. Sorry, 120 root 3. Right? So we have got this entire length as 120 root 3. A dash B. So by how much height must the tower be raised? This. Hence, the tower must be raised by 120 root 3 minus 120. Hence, the tower must be raised by a height x is equal to A dash B minus AB. 120 root 3 minus 120. Right? Now, have they asked you to express your answer? No. To any decimal place? No. So there's no restriction. You take 120 common, you get root 3 minus 1. So you get 120 into 1.732 minus 1. So you get 120 into 0.732. If you multiply this, you get 87.84 meters, and that should be your answer. So the building must be raised by, or the tower must be raised by a height of 87.84, so that the angle of elevation changes from 60 degree to 45 degree. And that should be your answer, and let's conclude this problem. Let's see the last problem. And there's a little bit to understand here in the last problem. The question is, an aircraft is flying at a constant height with a speed of 360 meters. Let's say this is your aircraft. And it is flying at a speed of 360 km per hour. Right? Let's say it is flying in this direction. Okay. From a point on the ground. Okay. And the height of this is, let's say the ground level. The height of this aircraft is given. Constant height. Okay. It's not given, but it is at a constant height. That means this plane aircraft is flying horizontally. Okay. It is not going vertically. Okay. It is flying horizontally. The height is constant. Okay. So let's say it is moving in this direction. From a point on the ground, the angle of elevation of the aircraft at an instant was observed to be 45 degrees. So let's say this is the point on the ground, and here you have your observer. He is observing the aircraft, and the angle of elevation of this aircraft is given to be 45. So what is the line of sight of this observer? This should be the line of sight of the observer, right? This is given to be 45 degrees. After 20 seconds, the angle of elevation was observed to be 30 degree. After 20 seconds, that means since the aircraft is flying here, let's say the initial position of the aircraft is B. And now after 20 seconds, it reaches, let's say, a point here, C. Okay. And now the angle of elevation changes to 30 degree. So what is the line of sight now? This straight line is the line of sight, new line of sight. And now the angle of elevation has changed to 30 degree, right? Question is, determine the height of the aircraft at which it is flying. So determine the height of the aircraft means, what is the height of the aircraft? If you see, this is your horizontal. Right? All this is your horizontal. And the height of the aircraft must be this height. Right? So you need to find out this height. Okay. Let us call this point A, and let us call this point B. Okay. So now we need to find out the height AD, the length AD, which is the height of the aircraft. Okay. So let's see how to find out the height. So if I say let H be the height of the aircraft, at which it was flying from B to C. Okay. Now what is the speed of the aircraft given? 360. And from B to C, what is the time taken to cover this distance? This distance is covered in 20 seconds, right? So BC, this distance is equal to speed into time, right? And what is the speed here? 360 kilometers per hour. Let's convert everything to meters. If you remember from your class 7 knowledge, that kilometer per hour when converted to meter per second is multiplied by 5 by 18. So I've converted this speed to meters per second, this speed. Okay, it was given in kilometer per hour. I've converted to meter per second. And you also have to multiply this by time. What is the time taken to fly? 20 seconds. Because time is given in 20 seconds, I converted to meter per second. Okay, so this, you can calculate this to be, this should come to 2000 meters. So that means this length BC is given to you. This length BC is 2000 meters. This length is given to you, right? So now if you see, if this length is given to you, this looks like your type 1 figure that we had discussed, right? Just inverted by rotated by 180 degree. This is like an inverted figure, isn't it? Now if you see, this angle here is 30 degree. This angle will be 30 degree. This angle is 45 degree. So this angle will also be 45 degree, right? Now we shall first use triangle ABD. In triangle ABD, tan 45 is equal to AD by AB, right? Okay, let's say this is also, this is X for convenience. Let's take AB is equal to X. So you get tan 45 is 1, AD is H, and AB is X. So that means you're getting H is equal to X. Call this equation number 1. Now we shall use the other triangle, which is triangle ADC. In ADC, we use tan 30 is equal to AD by AC. And tan 30 is 1 by root 3. AD is H. AC is X plus 2000. Entire length, if you see, this entire length is X plus 2000. Right? So now we have got two equations. Let's simplify this to get our second equation. So you get X plus 2000 is equal to H root 3. So you get H root 3 or 2000 is equal to H root 3 minus X. So you get H root 3 minus X is equal to 2000. Okay, call this equation number 2. Now we are going to solve equation number 1 and 2 to get the height of the plane, because we need to calculate H. So putting X is equal to H from 1 in 2, we get H root 3 minus, and instead of X you put H, is equal to 2000. So now you can take H common, you get root 3 minus 1 is equal to 2000. So now you get h is equal to 2000 divided by root 3 minus 1. Now you can rationalize the denominator. Root 3 plus 1 divided by root 3 plus 1 into root 3 minus 1. So you get 2000 times root 3 plus 1 divided by 2. 2 you can cancel here. 1000 times and 1.732 plus 1. So you get 1000 into 2.732. So you get 2732 meters. So this is the height of the aircraft, 2732 meters. Okay. You can convert it to kilometers also. Divided by 1000, you get 2.7 kilometers. So that concludes this problem also. So I'll stop here.